why it is happening. So synthesis and simulation mismatch can happen because of some reasons. Few of them I have listed here. It's called missing sensitivity list, blocking versus non-blocking assignments, non-standard Verilog coding. So let us look into what is missing sensitivity list. So let us understand this. So clearly in a Verilog code, now how a simulator works, let us understand how simulator works. The simulator works based on something called as activity. That is, the output will change only when there is a change in the input. Correct? Let's say, for example, I take an AND gate itself, a simple AND gate. Now, why the output is changing? If the output y is changing, the y will change because if there's a change in a, because there's a change in b. Correct? If neither a nor b changes, the y will not change at all. Correct? So a change in input only can cause a change in output. If all my inputs are stable, there is no reason for the output to change. So the simulator will look for activity. If there is no activity, it will not evaluate the output at all. That's the way simulator works. Now let us look into the code of this mux. Now what happens? Let's see. We see the always there's an input called I0 and I1. It's a 2 cross 1 mux. So there are two inputs and there's a select line and the output is a Y. Now what we are doing, always at select, whenever the select is changing, always at select. If the select is 1, my output is 1. If the I1, if else the output is I0. So what we are saying, I have a select. This is what we want. Correct. This is what we want. There is a select. There's a I0 input. There's a I1 input. If the select is low, connect. If the select is high, connect Y to I1. If the select is low, connect I input output Y to input I0. This is what we are trying to say. But what did we do here? Did we do any blunder here? The answer is yes. Now look at this always module, please. This always block. Please look at it. Now the always block is getting evaluated only when the select is changing. The always block is getting evaluated only when the select is changing. If the select is not changing, the always block is not getting evaluated. That means, let us see. My select is like this. This is my select. My I0 is here. Okay, my I1 is here. Like this. Now, when select is low, there are activities on I0. When select is high, there are activities on I1. But my always block is not sensitive to the activities on I0 and I1. Because of which, I will not see the output Y getting evaluated for changes in I0 and I1. When I do my RTL simulation, it will look as if this mux is like a latch. Only when select is high, only when there's a change in select, only when there's a change in select, here or here, the always block will get evaluated. When there is no change in select, here there is no change in select, here there is no change in select, but the outputs should get assigned to one of the inputs, right? But that will happen only when the always block is evaluated. My always block will not get evaluated at all. Like say for example, my select changed from 0 to 1 here, correct? The moment select changes from 0 to 1, my Y should follow I1, correct? Now Y should follow I1, that means the changes in I1, these changes in I1 should happen in Y. But these changes in I1 will not even be assigned to Y because the select, the always block is not sensitive to changes in I1. This is a mistake. This is what we call as the missing elements in sensitivity list. What is the correct way of writing it? Look at this. This everything is same. Everything here is same. Everything here is same. Nothing is changing. But look at the beauty here. Here I'm putting always at star. This means always is evaluated when any signal changes. That means for changes in I0 and I1 also, the always module will be always block will get evaluated, and at that point, that means what? These changes will now be seen here, whereas these changes will not be seen because of this. So now when you simulate this code, how it will look? When you simulate this code, these changes in I1 will not be seen in Y. So it will look as if Y is like a latch, because it is only when select is changing, or it's like a double-edged flop. Only when select changes, Y changes. If select is not changing, Y will not change. That's how simulation will look like. But in reality, in real, when you synthesize, the synthesizer is not going to look at sensitivity list at all. The synthesizer is going to look at the functionality here. And in synthesis, you will see a mux, which is what we intended to create. The synthesis will create a mux. So here the changes in I1 will be immediately seen in Y. So simulation will simulate as if it is like a double-edged flop. Okay, so in synthesis and simulation, clearly we will see a mismatch. The netlist behavior will be like this. The simulation model RTL behavior will be like this. We will have labs for this. We will see there in detail. Okay. Now